A very good day to sir. In this video, we're gonna present about our IoT mini project, which is the IoT Smart Lock System. I'm Tan Shijao and I will start the presentation. In this presentation, we had 4 parts, which is the introduction part, methodology, result discussion, demo part, and conclusion. First, I will present about introduction part. For project background, as we know, door lock is a device that is used for securing a door. Door lock is a standard feature for modern building. All the building in the current modern era will have a door and a lock. The common door lock that feature in household usually lacks security. There's this news that happened recently where burglar break into convenience store in Klang. Due to this weak door lock system, the door there lack any alarm system. Hence, when burglar break through, nobody knows, and a lot of money is lost. To solve this security issue, IoT door lock system was introduced. This IoT door lock system implements controller and sensors into the door lock. It uses a cloud application that lets users to unlock door. The application is featured in iOS and Android mobile application. This IoT door lock system also had a built-in alarm system, so when the door being forced open, alarm will go off. Thus, this proposed system provides security measure feature. Next, I will present about objective. This proposed system helps to enhance the security of a household. Furthermore, users won't have to worry about the problem of losing keys since users lock and unlock door with their phone. The objective of this project is to design and develop a system that lock and unlock door using IoT interface, to develop a system that monitor door status through internet, and to develop an alert system if the door was opened without authentication. The hardware used in this project is not MCU ESP8266, solenoid door lock, relay, buzzer, and magnetic switch. Software side, we use Blink, which provide interface for IoT application. The project scope is that the targeted user are people with land property, house, company or school. Limitation wise is that the project has to work under Wi-Fi coverage area.
Hi, my name is Naim and I will be explaining on our project's block diagram and flowchart. For the system block diagram, ESP8266 will be connected to the cloud and the Blink application. The ESP8266 works as the hardware part in the IoT system, whereas the Blink application provides the necessary API, or what we call the user interface for the system. The cloud, on the other hand, is the Blink server that acts as an intermediary between the hardware and the user. For the Node MCU ESP8266 block diagram, Blink application and a magnetic switch will be connected to the Node MCU as an input, while buzzer and a relay that is connected to a solenoid door lock will be connected to the Node MCU as the output of the system. Next, I will be explaining on the flowchart of the system. The flowchart of the system begins with an execution of the system that will be executed forever as long as it is powered by a power source and connected to the server. While running, the system will continuously check for the status of the door and the door lock. If the door is closed and locked, the system will do nothing and check for the status of the door and the door lock again. On the other hand, if the door is currently closed and the door lock is unlocked, the system will notify the user and the user is required to make an input from the Blink application. Another possible route of the system is that if the door status is currently open, it will then check if there is any input on the door lock for the last 5 seconds by the user. If the user has unlocked the door for the last 5 seconds, the system will wait for another 20 seconds and repeat the process of status checking on the door and the door lock. But if the user did not unlock the door lock for the last 5 seconds, the buzzer will be triggered and the system will notify the user for security breach. The buzzer will keep running and user will be receiving notification until the door lock is locked again to indicate that the user is aware of the security breach. This cycle will repeat forever until deemed unnecessary.
Hello, my name is Muhammad Zahiruddin and I am going to talk about the circuit, connection and our component. Our component consists of Node MCU, which is a microcontroller with a Wi-Fi feature and 8-pin input-output. This is enough for our IoT project. To make a door lock system, we need to have a lock, a sensor and an alert. For lock, we will use a solenoid lock, and for sensor, we will use magnetic switch. For alert, we will use a buzzer. For the locking system, we will use a solenoid lock because it can be actuated using a 12-volt voltage supply. And since our board can only support 3.3 volt, we need to use a 3-volt relay. The connection on the relay is normally open so that our door will stay locked in case of power cut off. To open the lock, 3.3 volt is sent to the relay input so that the relay is connected and the lock is powered up by the supply. Then for the sensor, we will use a magnetic contact switch. When there is a magnet in the proximity of the magnetic switch, the magnetic switch will complete the circuit. This will be used to check the state of our door. We use this configuration, which is an active high configuration, so that the circuit will send a high signal when the switch is intact. This switch will be placed on the side of our door so that the magnetic switch will be intact when the door is closed. Lastly, for our alert system, a buzzer is connected to one of our data pin and it will alert the people surrounding in case of burglary. This can be changed to a louder buzzer for a better alert system. And on the right of this slide is our circuit. So that's all for me. I will pass to my next team member.
Good day, sir. My name is Jana. I'm going to present result, demo, and discussion. This is the hardware setup. It only needs magnetic switch and solenoid door lock. All of component is connected well. To open the door, just unlock from phone, then solenoid and magnetic switch is enabled. Then if the door is open for more than 2 minutes, user will be notified that the door is open. Then when the door is closed, the solenoid and magnetic is disabled. When the door is open forcefully, the notification is display security breach from phone lock. And alarm will beep long. This is the hardware setup, while the second part shows the complete setup. The circuit of the project is built in a box to ensure that the wire connection won't get interference when deploying at the door. Furthermore, the project is easier to implement as only the mechanical switch and solenoid door lock is needed to be installed at the door. There are 3 achievable results that can be observed in this project, which is lock and breach, lock and unlock. Lock and no breach happen when the door is currently closed and locked. The solenoid is enabled, which indicating that the door is locked and currently closed. The LED widget on the application is turned off when the door is closed, and the segment switch widget is currently showing that the door is locked. The lock and breach happen when the door is open forcefully. The LED switch on the application is turned on when the door is open. In this situation, the segment switch widget is currently showing that the door is locked. Thus, an alarm is beeping and notification is sent to the user to prompt that the security of door has been breached. The door unlock happens when the door is open and unlocked. The LED widget on the application is turned on and notification will prompt the user, letting the user know that the door is being opened. The segment switch widget is currently showing that the door is unlocked. This report was done in concern of developing a proposed system to enhance the security of household. The proposed system was developed with the ability to interconnect with IOT. The designer system works as when the door is unlocked from the phone, the notification door is open from link is displayed from the lock screen, then the solenoid is enabled to indicate that the door is currently open. When the door is closed, the solenoid is disabled to indicate that the door is currently closed, but when the door is opened forcefully, an alarm is beeping and the notification displays security breach from phone lock screen. Here is the demo.
Throughout this project, the objective of the project have been achieved. The first objective is to develop a system that lock and unlock door. The Bring mobile application here was connected with the controller. It can lock and unlock the door just by clicking on the button on the apps. The second objective is to develop a system that monitors door status. The mobile application provides real-time monitoring feature. User can check the door status just by checking the application. The third objective is to develop an alert system. When the door is being forcefully opened while locked, an alarm will go off, and the notification will pop up at the mobile application. In conclusion, this system not only resolves the security issue of the old door lock system, it also provides extra features to enhance the old door lock system. The simplistic mobile application also provides convenience to user. For the future improvement, there's 3 major improvements that can be done. The first one is offline authentication. The current door lock system requires system to online to authenticate user to lock or unlock the door. For future improvement, user can lock and unlock the door still using the apps, but user is not required to connect it to internet. The second improvement is backup battery. This is to make sure that when there's a power outbreak or any emergency happen, the door still can be unlocked by the app. The last improvement is integration in a smart home system. That's all from us. Thank you.